Welcome back. We're going to continue our discussion of chemistry as it relates to biology. And in the first unit, we learned a little bit about the elements themselves. We learned what molecules are, what compounds are. And let's go back and look more specifically at the elements, and in particular, what the subatomic particles are. How do we find out how many electrons, protons, and neutrons an atom has? And that information is in the periodic table of the elements. And so when we look at an element, in this case we're going to use scandium, which has the symbol Sc. We're going to look at two specific numbers that give us a lot of information about that. The atomic number and the atomic mass, which is sometimes called the mass number. So we're going to look at those two, and probably the more important of the two, the atomic number, tells us the number of protons. It defines the element. So if someone says that, hey, I've got an element and it has 6 protons, we can look at the periodic table and say that is carbon. Whereas if they say it's 7 protons, it's no longer carbon, that happens to be nitrogen. So the atomic number is very important because it tells us what the element is. The atomic mass, or the mass number, is the number of protons and neutrons. And the same element sometimes can have different atomic masses, and later on we'll talk about isotopes. But for right now, just know that the mass number of the atomic mass is the number of protons and neutrons. So when we look at an element, sometimes they'll use this notation, if we look over in the lower left here, called the AZX, where the X is the name of the element, whether it's C for carbon, Sc for scandium, the symbol for V for vanadium. A in the upper left is the atomic mass. So this is the number of protons plus neutrons. And in the lower left here, the Z is the atomic number. So that will be the number of protons. So in the case here, if they give us scandium, 45 and 21, we look at the lower left, the 21, right away we know that it has 21 protons. That's the definition of the atomic number. And because it's a neutral atom, we know that the number of protons and electrons has to be the same. So the number of electrons is also 21. But in this case, 45 is the number of protons plus neutrons. Well, we know there's 21 protons, so 45 minus 21 gives us 24 neutrons. So you need to be able to take the information from the periodic table in terms of the atomic mass and the atomic number and figure out how many electrons, protons, and neutrons an atom has. So again, just kind of to rehash, the atomic number is the number of protons. Okay? In an atom, it's called the atomic number. It distinguishes one type of atom from another. Like I said before, it defines the atom. So here's an example of carbon-12. The atomic number in this case in the blue is 6. That's never going to change as long as it's carbon. And the atomic mass in this case is 12. There's also carbon-13. There's carbon-14, which you may remember from earth science when you talked about radioactive dating. So here's an example of bromine. So this is from the periodic table, and the setup's a little bit different if we look at this. So again, if we look at this one, let's look at the 35. So that's the smaller of the two numbers, and on the periodic table, that will often be on the top, and that's the atomic number, or the number of protons that are there. The lower number, 79.9, is the mass number of the atomic number, and it's protons and neutrons. And one thing I want you to just kind of notice real quickly here is, can we have 9/10 of a proton or neutron? We can't. Those usually would be whole numbers like 80 or 79 or 2 or 3. But this is something called the average atomic mass. And when we talk about isotopes, it'll make more sense. But for right now, we're just going to assume that it's a whole number. So in this case, we're going to round it up to 80. So by looking at this, we can tell, hey, 35, that defines the element. That's the number of protons. So we've got 35 protons. And what did we say about the number of protons and electrons in a neutral atom? We said that they were the same, so the number of electrons also has to be 35. Now, if we want to find the number of neutrons, what we have to do is we've got to take the atomic mass, which in this case will be 80. Remember we said we rounded 79.9 up to a whole number, minus the atomic number, which is the number of protons. And when we do that, we're left with just the number of neutrons, and we get the number of neutrons equals 45. So just by using these two numbers, the atomic number and the mass number, we can find the number of protons, electrons, and neutrons in any element from the periodic table as we go through there. Okay, so the number of neutrons is going to be found by taking the atomic mass and subtracting the atomic number. So you've got to be able to look at a periodic table, look at some data that's given to you, and be able to figure that out. So here's a case of phosphorus. So in this case, it's phosphorus 31. So the number of protons is going to be 15. That's given to us as the atomic number right there. And as we said before, what's true of the number of protons and electrons in this case, because it's a neutral atom, they're going to be equal. So we also have 15 electrons. Well, then we just take our atomic mass, given to us as 31, we subtract the atomic number 15, and we get that there are in fact 16 neutrons for that. So why don't we go ahead and we'll try a couple examples. So here's an example of sulfur. So why don't you take a second, take a look at this, and see what you get for protons, neutrons, and electrons. Okay? So let's start off. The easiest one should be the number of protons, because the protons, as we said before, is just going to be equal to the atomic number, which in this case, from the symbol here, is going to be in the upper left. So that's going to be 16 protons. Which subatomic particle should be next to get? Well, if we remember that the atom is neutral, the electrons must be the same number, so the number of electrons is also going to be the same. And in this case, neutrons is going to be the mass number minus the atomic number. And in this case, the mass number down here is going to be 32. And again, we'll round to a whole number, as we'll see in a little bit, minus 16. So in this case, it works out that the number of protons, electrons, and neutrons are all the same with 16. So let's try one more. Let's look at arsenic. Okay, so again, how many protons will we have? Where are we going to look on the periodic table? Where are we going to look on the element symbol here? Well, we should look in the upper left-hand corner, and we'll find out that there are 33 protons. And the next one should be pretty easy. If we've got 33 protons, we also have 33 electrons. And in this case, the number of neutrons is going to be equal to the atomic mass, or mass number. Again, this one will round up, so it's going to be 75. Subtract the atomic number, and so we're going to end up with 42 for our number of neutrons. So now, with the information that you just learned, you should be able to go through for any element on the periodic table and find the number of protons, electrons, and neutrons in that atom. And just remember, who said that chemistry is difficult?